Hello and welcome to 7.2, Sum and Difference Identities. So sum and difference identities. First, the sine identities. If you were to do sine of a sum, you're going to have sine u times cosine v plus cosine u times sine v. That's something you really want to memorize. It's something you don't want to have to be fumbling around with when you need it, because it'll take you much longer every time you're looking this up. Sine of u minus v is sine u cosine v minus cosine u sine v. Again, something to memorize. In fact, these are all things you should memorize. Note cards by the mirror, things like that. Cosine identities, cosine of u plus v is cosine u cosine v minus sine u sine v. So notice this one has the cosines together and the sines together, but for the sum, it's a minus here. Cosine of u minus v is cosine u cosine v plus sine u sine v. Tangent identities. You could always find tangent by doing sine over cosine, but tangent of u plus v, here's another way. Tangent u plus tangent v over 1 minus tangent u times tangent v. Over here, tangent u minus tangent v, they look very similar. The thing is the negative and the positive switch places. Tangent u minus tangent v over 1 plus tangent u tangent v. So let's go ahead and apply this. So use the sum and difference identities to determine the exact values of the expression. I realize you could plug this in the calculator. I want to use this the way it's intended. So sine, it's going to be sine of the first one, pi over 6, cosine of the second one, which is 3 pi over 4, plus sine of 3 pi over 4, cosine of pi over 6. And you could say cosine pi over 6, sine 3 pi over 4. Multiplication is commutative, so let's not worry about that. So sine of pi over 6 is 1/2. Cosine of 3 pi over 4 is negative square root of 2 over 2. Sine 3 pi over 4 is positive square root of 2 over 2, and cosine of pi over 6 is square root of 3 over 2. So we have negative square root of 2 over 4, you multiply here, this is a negative, plus the square root of 6 over 4, so you can write that as square root of 6 minus square root of 2 all over 4. Okay, following the formula. Now we have cosine of a sum. So remember how this was? The cosines were together, the sines were together, and it was a minus between them. So we have cosine of pi over 3 times cosine of 11 pi over 6 minus sine of pi over 3 times sine of 11 pi over 6. So this is going to be 1/2 times square root of 3 over 2 minus, now sine of pi over 3 is square root of 3 over 2, sine 11 pi over 6 is a negative 1/2. So that's going to be the square root of 3 over 4 minus a negative square root of 3 over 4. So it's square root of 3 over 4 plus the square root of 3 over 4. 2 times the square root of 3 over 4, and that reduces to be the square root of 3 over 2. Next one, tangent of 4 pi over 3 minus 5 pi over 4. This is going to be tangent of 4 pi over 3 minus tangent of 5 pi over 4 over 1 plus tangent of 4 pi over 3 times tangent of 5 pi over 4. Now tangent of 4 pi over 3, that's going to be in the third quadrant. That's going to be the square root of 3. Tangent of 5 pi over 4 third quadrant. So that's going to be 1. We have 1 plus the square root of 3 times 1. Let's think about this for a second. This would be pi over 3, 2 pi over 3, 4 pi over 3, and then over here was 5 pi over 3. Yeah, that's correct. Tangent of 4 pi over 3 is 1. That's square root of 3. Okay, so what we have is square root of 3 minus 1 over 1 plus the square root of 3. Now, we could leave it like that, but we probably should rationalize the denominator. Multiply by 1 minus the square root of 3 over 1 minus the square root of 3. So we have square root of 3 times 1 is square root of 3. Square root of 3 times negative square root of 3 is minus 3. Negative 1 times 1 is minus 1. Negative 1 times negative square root of 3 is plus the square root of 3 over, then down below it's a multiplication, a sum and difference multiplication. That's going to be a 1 squared minus square root of 3 squared. So we have 2 times the square root of 3 minus 4 on top. Down below we have 1 minus 3. So it's 2 times the square root of 3 minus 4 over negative 2. And we can divide that out. Negative square root of 3 plus 2, or 2 minus the square root of 3. Okay, now we're going to use the sum of different identities to determine the exact values of the following. I realize some calculators can be put in exact mode and give you quote-unquote exact values. It's important to see how we do this by hand though. So tangent of 150, you could think of this as tangent of 180 degrees minus 30 degrees. So that's going to be tangent of 180 minus tangent of 30 over 1 plus tangent of 180 times tangent of 30. And this is just one of the choices. We could have done something like 90 and 60. We could have done something like 120 and 30, adding them. I did a subtraction. Now tangent of 180 is 0. Tangent of 30 degrees is square root of 3 over 3. And then we have 1 plus 0 times square root of 3 over 3. So this is going to be negative square root of 3 over 3 over 1. So just negative square root of 3 over 3. Sine of 270. Think of this as sine of 240 degrees plus 30 degrees. Now that's one option. We could have done 180 plus 90. Let's just go with this. So we're going to have sine of 240 degrees cosine of 30 degrees plus sine of 30 degrees cosine of 240 degrees. So sine of 240 is going to be negative square root of 3 over 2. Cosine of 30 is positive square root of 3 over 2. Sine of 30 is 1/2, and cosine of 240 would be negative 1/2. I'm sorry, cosine of 240 is, let me just, that should be right. So this is going to be negative 3 over 2. I feel like I should have a double negative here. Let me check my formula. Sorry, square root of 3 over 4, there's my problem. Okay, now I feel better. Minus a 1/4. So that's going to be negative 3 over 4 plus negative 1/4 is negative 4 over 4, and that's going to be negative 1. There we go. Trying to get worried there. Okay, so I did a sine of 240 plus 30, that's sine 270. We know sine 270 is negative 1, and that helps to verify it. Now the next one is one that we would not have known. This is not one of the standard values that we've seen before, but you're going to see this on quizzes and things like that, so be aware something like this type of problem, so be aware how we break this down. Cosine of 7 pi over 12. Now I'm breaking this down to say cosine. Now we want things that we know. We don't know anything divided by 12. But we would know, think of things that add up to be 7. Like 3 pi over 12 plus 4 pi over 12. Now these will both reduce. This is then cosine of pi over 4 plus 4 pi over 12 is pi over 3. So it's cosine of pi over 4, cosine of pi over 3, minus sine of pi over 4, times sine of pi over 3. So cosine of pi over 4 is square root of 2 over 2, times cosine of pi over 3 is 1/2. Sine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. That's the square root of 2 over 4 minus the square root of 6 over 4. So it's going to be the square root of 6. Well, I guess we could leave it like that, couldn't we? I'll do square root of 2 minus square root of 6 all over 4. That's the exact value. If you want a decimal answer, it would be an approximation. Okay, for our next one, scroll too high there. Sine of alpha is 4/5 and sine of beta is, I can't read it, 5/13. Both alpha and beta are in quadrant 1, so that's good to know because when we try to find cosine of alpha minus beta, we know it's going to be quadrant 1. Well, we know we're talking about alpha and beta being in quadrant 1. We don't know about the alpha minus beta. So let's draw a little picture here. Here's alpha. Sine of alpha is opposite over hypotenuse, so 4 over 5. And let's call this last side b. B squared plus 4 squared equals 5 squared. So b squared plus 16 is 25. B squared is 9, so b is 3. That allows us to find cosine of alpha. Cosine is the adjacent side over the hypotenuse. And we know sine of beta. Let me draw it the other way. Here's our beta. Sine of beta is going to be, well, it always is, it's opposite over hypotenuse, so it's 5 over 13. So we call this side A. A squared plus 5 squared equals 13 squared. A squared plus 25 is 169. So A squared is 144 and A is 12. So that cosine of beta would be the adjacent side over the hypotenuse, 12 over 13. Now we have all the information we need to put this together. We know sine of alpha, sine of beta, cosine of alpha, cosine of beta. So cosine of alpha minus beta is cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. That's going to be, well, cosine of alpha, we determined that was 3/5. Cosine of beta is 12/13, excuse me. Sine of alpha, we were told, is 4/5, and sine of beta is 5/13. We end up with 36 over 65 plus 20 over 65, or 56 over 65. Now the next couple are kind of fun, because we go from this statement that's all expanded to a more compact statement. So use the sum or difference identities to rewrite each of the following expressions as a trigonometric function of a single number, and then evaluate it. Here we have cosine of 5 pi over 12 times cosine of 2 pi over 3 plus, that's key, sine 5 pi over 12 sine 2 pi over 3. That's going to be cosine, because you have cosines together, sines together, it's going to be a cosine, and it's going to be a difference because it's the opposite of the sine here. Cosine of 5 pi over 12 minus 2 pi over 3. That's cosine of 5 pi over 12 minus 8 pi over 12. I multiply both top and bottom by 4. So that's cosine of negative 3 pi over 12, which is cosine of negative pi over 4. Well, cosine of negative pi over 4 is the same thing as cosine of pi over 4, because it's an even function. So that's going to be the square root of 2 over 2. And the next one's a tangent. Now this says tangent 5 pi over 12 plus tangent 3 pi over 4 over 1 minus tangent 5 pi over 12 times tangent 3 pi over 4. So this is obviously a tangent one. Not a lot of guessing there. It's going to be a tangent. We're going to have our 5 pi over 12, and we're going to have our 3 pi over 4. The question, is it plus or minus between them? Well, the key is right here. It's plus here, so tangent's going to be plus as well. It's not like cosine that was the opposite. So we want to add these up. So this is tangent of 5 pi over 12 plus, now to make forward a 12 in the denominator, multiply by 3. So 3 over 3 gives us 9 pi over 12. So this is tangent of 16 pi over 12, which is tangent of what? 16 reduces with 12. We could divide a 4 out, 4 pi over 3. And tangent of 4 pi over 3, what's that going to be? Isn't that going to be just a negative square root of 3? I think I added wrong. 9 plus 5 is not 16, it's 14. Okay, let's do this right now. So this can be reduced to be tangent of 7 pi over 6. Okay, that's a little different. And that's going to be negative square root of 3 over 3. Okay, now we're good. Okay, feel free to pause that. I'm going to move on to example 5 here. Use the sum or difference identities to verify the identity. So here we have sine of beta minus theta plus sine of beta plus theta equals 2 times sine of beta cosine theta. So start with this one. Sine of beta minus theta would be sine beta cosine theta minus sine theta cosine beta plus sine of beta plus theta, sounds like a Dr. Seuss thing, is going to be sine beta cosine theta plus sine theta cosine beta. Now, I have a sine beta cosine theta and another sine beta cosine theta. my red pen here. I have a sine theta, a negative sine theta cosine beta, and a positive sine theta cosine beta. Those subtract out. And I'm left with 2 times sine beta cosine theta. 1, 2. And that works. Identity is valid. Now our next problem, we're going to use the calculator for it. I'll bring that onto the screen. Let me scroll to the next problem first. It says, use a graphing calculator to determine if the following identity is true. And so let me program this in first. We have cosine of theta, in this case just x minus 3 pi divided by 2. I know you can't see this yet, you will in a second. And the next one's going to be negative sine of x. So we want to see on a graphing calculator that this is true. So let me go over here to this mode and you can see the calculator. So I programmed cosine of x minus 3 pi over 2 and negative sine x. So we're going to see they're going to line up on top of each other. So right now they're both check marked. I'm going to turn off this negative sine x. It's turned off. So when I graph, I'm just going to see the cosine. Let me do my window here. I'm going to go from, I don't know, let's go negative pi to 3 pi. And we're going to do our scaling by pi divided by 2. We'll go negative 1.5 to 1.5. Because sine and cosine only produce as high as 1. And I do need to change my mode because my mode is in degree mode. So I'm changing this back to radians. On the graph. So here's our first function. This is cosine of theta minus 3 pi over 2. Now, I'm going to go back to my y equals. I'm going to turn off y6. And hit F4, unchecks it. I'm going to turn on y7 and graph that. Does it look like it lines up there? Okay, so it looks like it's doing the same thing, but just to be sure, I'm going to graph them now both on at the same time. So I'm going to go ahead and turn this on as well. And it's actually working. I don't see anything being drawn other than what's already on the screen, so that means it's drawing on top of what's there. So in fact, I can have it regraph. So that means it's graphing the first one. And knowing that the other graph was in the same general area, it's on top of it. Well, I want to point out something. If I put something in here like y equals 50, you wouldn't see it because it's way up beyond where this graph is going to be. So my point in saying that is that it's important to make sure both graphs are in the same window and then to see if they're on top of each other. Okay. I'm going to go on to example 7. Express the following as an algebraic function of x. Sine of arctangent 2x minus arc cosine 2x. So what I want to do first is define some things. What if I said theta equals arctangent 2x, and if I said phi, this is the Greek letter for phi, is arc cosine 2x. This becomes sine of theta minus phi, and we're not too intimidated by that. We know what that is. That's going to be a sine of theta cosine of phi minus sine of phi cosine of theta. That's what it means. So The important thing is now to find out what theta would be. Well, this can represent a triangle. You can think of this as tangent of theta is going to be 2x. Tangent of theta is 2x, so we draw ourselves a triangle here. If this is theta, the opposite side is 2x, the adjacent side is 1. You can think of it as 2x over 1. And the hypotenuse, c squared is equal to 1 squared plus 2x quantity squared. So c squared is 1 plus 4x squared. So c equals the square root of 1 plus 4x squared. That's our hypotenuse. Now we can use that when we try to find sine theta, cosine phi, sine phi, and cosine theta. We've got to do the phi part next. Now cosine of phi would be 2x. So if we draw a triangle here, think of it 2x over 1. The adjacent side is 2x. The hypotenuse is 1. So 2x squared plus b squared equals 1 squared. 4x squared plus b squared equals 1. B squared is 1 minus 4x squared. So b would be the square root of 1 minus 4x squared. So that this side must be the square root of 1 minus 4x squared. So let's finish this off. We have our triangles. We know the sides of these triangles, so we could find these relationships. Sine of theta. Sine of theta is going to be the opposite over the hypotenuse. So we have 2x over the square root of 1 plus 4x squared times cosine phi. This is my phi. Now I probably didn't have to do the cosine phi one because the cosine of our cosine cancels out, but it kind of reinforces it. Cosine phi is the adjacent side over the hypotenuse, so that's our 2x over 1, minus sine of phi. Sine is going to be the opposite over hypotenuse, the square root of 1 minus 4x squared over 1 times cosine of theta. Cosine of theta is going to be the adjacent over the hypotenuse, so 1 over the square root of 1 plus 4x squared. So 4x squared over the square root of 1 plus 4x squared minus the square root of 1 minus 4x squared over the square root of 1 plus 4x squared. So that's the next step there. Notice they have the same denominator, so we could bring them together in the numerator. 4x squared minus the square root of 1 minus 4x squared over 1 plus 4x squared. Now I'm going to leave it like that. Oh, sorry, not still a radical there. I'm going to leave it like that. Even though there's a radical in the denominator, I think to go any further is going to make it really too messy. So this kind of goes against our standard way of writing things, but that's where we're going to leave it. And I would take that answer. Okay, a lot of work on that one. We have one more problem from this section. So I'm going to go ahead and pause if you want some more time on this. I'm going to scroll this up and talk about this sum of sines and cosines. Now, to sum up a sine and a cosine, for example, like you have a sine x plus b cosine x. By the way, a and b could be one, they could be something else, but they have to be the same angle as x. The sum is going to end up being square root of a squared plus b squared times a over a squared plus b squared sine x plus b over a squared plus b squared cosine x. Really, this step you can kind of skip. This is showing the development. This is the final answer. The square root of a squared plus b squared times sine of x plus phi. Now you're asking, what's phi? Well, phi is going to be, cosine of phi is, so you have these two things to look at. Cosine of phi is a was the coefficient for sine over the square root of a squared plus b squared. Sine of phi is b, that was the coefficient for the cosine over the square root of a squared plus b squared. So it's the angle that satisfies both of these conditions. And that leads us to this example. Express each of the following functions in terms of a single sine function and graph the result. So we have g of x equals sine x plus square root of 3 cosine x. So in this, our a is 1 and our b is the square root of 3. So g of x will be the square root of, remember it's a squared plus b squared sine of x plus phi. So right off we know it's going to be the square root of 1 squared plus square root of 3 squared sine of x plus phi. So g of x would be 1 squared is 1, square root of 3 squared is 3, 1 plus 3 is 4, square root of 4 is 2 times sine of x plus phi. So what's phi? Well, let's start with cosine. Cosine of phi is a over the square root of a squared plus b squared. So cosine of phi is 1 over 2. Because our square root of a squared plus b squared is 2. Sine of phi is going to be b over the square root of a squared plus b squared. So sine of phi is going to be square root of 3 over 2. So what angle satisfies the cosine of phi is 1/2. Sine of phi is square root of 3 over 2. Well, phi must be pi over 3. Hey, I rhymed. So g of x is 2 times sine of x plus pi over 3. And that's it. And I believe that does it for this section. Let me just verify. Yes, it does. Okay. So that's it for this section. Please send me your questions. Thanks. Bye.